Hi there. Today we are looking at part B of HSC Mathematics paper 2011, question 10. A farmer is fencing a paddock using P meters of fencing. The paddock is to be in the shape of a circle with radius r and sector angle theta in radians, as shown in the diagram. So basically, here we have a sector with a radius of r and with the central angle of theta. And we want the perimeter of this sector to be equal to a certain amount of P. Part I show that the length of fencing required to fence the perimeter of the paddock is P is equal to R bracket theta plus 2. If we have a sector with a central angle of theta and a radius of r, the perimeter of that is composed of this radius and this radius, which together becomes 2r, and the length of this arc, which is equal to r times theta in radians, so r theta. So the perimeter is going to be 2r plus r theta, which if we factorize for r, we get 2 plus theta as required. That is for part I. For part II, show that the area of the sector is A is equal to half times PR minus R theta squared. We know that the area of the sector is given by half R squared theta. That is the area of a sector. In this equation, we have both r and theta. But in the given equation, they have only r, no theta. And remember, P is just a constant value. So we need to find a way of expressing theta in terms of r. So the final equation for area has only r in there. Using the previous part, we can do that. So we have P is equal to r, 2 plus theta. That's from part I. And excuse me. And then we need to find theta from here and sub in that. So I divide both sides by r. I get P over r is 2 plus theta, and I subtract 2 from both sides, so get PR minus 2 is equal to theta. Now I express theta in terms of P and r. So we substitute now in the area. So area is half r squared times theta, which is now this. P on r minus 2. If we expand this bracket, we should be able to get that. So A is equal to If I times this by PR, half r squared times PR, one of the r's cancels out. So you end up with 1r, and you have a 2 in the denominator, or you can keep it as half the way they put. So half times PR, that part. Then you have a minus. And when you expand that, that 2 and half cancels out, you end up with just r squared. R squared. That is the answer for part 2. For part 3, find the radius of the sector in terms of P that will maximize the area of the paddock. So using the expression we had for area from part 2, to maximize any quantity, we need to differentiate its given value in terms of variable that they are given, and then solve that derivative equal to 0, or put it equal to 0, and solve for the value, and later on check to see if it is a maximum. So what I'm going to do now, I'm going to differentiate with respect to r. That will give us half p minus 2r. Then I put the derivative equal to 0. That gives me half p minus 2r equal to 0. And from that I find the value of r. So half p is equal to 2r. Divide both sides by 2, you get a quarter of p is equal to r. So that value of r is likely to give me the maximum possible area. But we need to check it. To check, you can go to the second derivative. That's the first derivative, and we're differentiating for the second derivative. We're differentiating it to get the second derivative. So this is, remember, a constant, p, because p is a given value. So that becomes 0, and minus 2r becomes just minus 2. So because this is less than 0, that means that we have a concave down curve when you graph A versus R. So as a result, you will have a maximum value for any stationary point. So even I don't have any R here, so obviously I have one stationary point, and at that stationary point I'm going to have a maximum. So for R is equal to a quarter of P, A is a maximum. Okay, that is for part 3. For part 4, find the angle theta that gives the maximum area of the paddock. So we know what is the R value, which will result in maximum area of the paddock, but now they want the value of the theta when the area of this paddock is a maximum. So remembering that P and R and theta are given by this equation which we had in the first part, and knowing that when area is maximum, R is a quarter of P, we can use these two pieces of information to find the theta when area is a maximum. So then P is equal to, in place of R, I'm going to put a quarter of T in this. And then you can eliminate P from both sides, divide both sides by P. Times both sides by 4 to get rid of this quarter. So that becomes 4, and the quarter just disappears, and I don't need the bracket anymore. And from here, take 2 from both sides, we get theta is equal to 2. So when your area is a maximum, the value of central angle for your sector is 2 radians. For part 5, explain why it is only possible to construct a paddock in the shape of a sector if P over 2 bracket pi plus 1 bracket close is less than R, which in turn is less than P on 2. So basically we have two inequalities here, and we need to show that these inequalities must be met, so we can have this paddock in the form of a sector. For the first one, you know that when you have a sector, maximum value for theta is 2 pi. Maximum value of theta is 2 pi. Using this and the fact that we had P is equal to R theta plus 2 from part I, P is always equal to this value, and the fact that theta max is 2 pi. So if I put 2 pi here, P must be less than that, because then this becomes the greatest possible value in terms of practicality of having a sector. So then P is less than R. In place of that, I'm putting 2 pi. 2 pi plus 2. And if I divide both sides by this bracket, I get P divided by 2 pi plus 2 is less than R. Remember that I can divide by this bracket because this is a positive value. And then if I factorize for 2 in the denominator, I'm going to get P over 2 pi plus 1 less than R, which is the first inequality. So all we needed to know is that the maximum value of theta has to be 2 pi. That is the first bit. For the other inequality, we got to show that R is less than P on 2. Again, using the same inequality that we had, P is equal to R theta plus 2. So P is equal to R theta plus 2R. Again, to have a sector, theta has to be greater than 0, because otherwise, if theta is 0, we don't have a sector. So this should be a positive value. And that means that P is larger than 2R. P is larger than 2R because theta has a value and R has a value. And dividing both sides by 2, you get P over 2 is greater than R, which is the second inequality. Thank you very much for watching.